Welcome to qnawire.
So this question says that red LEDs were originally made from GaAs, which has a band gap of 1.43 eV, and GaP, which has a band gap of 2.26 eV. And we want to determine what the X is in a combination GaPX AS 1 minus X when lambda equals 660 nanometers. And so 660 nanometers is 6.60 times 10 to the negative 7th meters. And so we can use the equation E equals HC over lambda to determine what the band gap of this composition is. And so that would be H, Planck's constant, 4.1357 times 10 to the negative 15th eV seconds, times the speed of light, 2.998 times 10 to the 8th meters per second, and then divided by the wavelength, 6.60 times 10 to the negative 7th meters. And that gives us a band gap of 1.88 eV. And so now that we have that, we can determine the percent variation of this from each of the band gaps. And to do that, we just take the total difference between the GaP and the GaAs band gaps, and then the difference of each of them from this E to determine the percent difference between those. And so doing that gives us that we have the percent for GaAs is 0.45 divided by 0.83. So that's the difference between GaAs and this band gap over the total difference between GaP and GaAs. And that gives us 54%. And when we do the same thing for GaP, we get 46%. And so to find out what our X value is, since the X is for the P, we'll go with our 46%. And so our X will be equal to 0.46. And that's our final answer.